Hi, welcome to my presentation about how habitable the solar system is. Come over here. Whoa, too close, back off, would you? I put together a scale model of the solar system to look at, and we'll learn a bit about the habitability of celestial objects. I'll help you on your way and send you right over to Mercury. Mercury's a surprisingly strong contender if you just want to live there. The downside is you would be restricted to places in perpetual shadow, as sunbathing, well, exposes you to radiation. This downside isn't as bad as the shadows are where the water is. The location and turn size limitation isn't a problem because we would have to live in pressurized shelters, as Mercury doesn't have an atmosphere due to its small size and proximity to the sun. Meaning, if you're fine living inside all the time with an occasional walk in the darkness, Mercury is your place. However, the next planet in our lineup isn't so friendly.
Mercury in the model is on average 12.5 meters away from the Sun. This is a very dangerous place for humans and spacecraft due to solar wind, which is a stream of charged particles. Fortunately, Mercury has a magnetosphere, aka the planet is a giant magnet that deflects the solar wind most of the time.
Unlike Mercury, Venus is an interesting place, from afar. It's impossible to put boots on the ground, let alone living there, as Mercury's problematic lack of an atmosphere is flipped on its head and is swapped to too much atmosphere, as even military submarines would be crushed like a tin can on its surface. Forgetting the pressure, its atmosphere brings more issues, as Venus is the hottest planet in the solar system due to its greenhouse effects. So, you can't live there. Moving on.
Venus is on average 23 meters away from the Sun, and the closest planet to it on average is Mercury. Venus lacks a magnetosphere, and its atmosphere is constantly being stripped away by the solar wind. Despite all of this, it's my favorite planet.
We all know Earth, and we think of it as a habitable planet. This is not a default option, it is an extreme exception. There are minor issues with radiation that could cause sunburns, but otherwise not too many issues that could cause Earth to be inhabitable in the near future.
Earth is on average 32 meters away from the Sun, and the closest planet on average is Mercury. Earth is pretty cool, I happen to live there, and I suggest visiting it sometime.
Mars is very prominent in science fiction, mainly due to its proximity to Earth and with dreams to terraform it. These dreams are nothing like reality. Terraforming Mars is an almost impossible endeavor, as to solve almost all of Mars's issues with radiation, oxygen, and temperature, it would require Mars to have a substantial atmosphere. Ignoring the lack of magnetosphere, Mars doesn't even have enough mass to retain any meaningful atmosphere, making the solution to living on Mars almost the exact same as Mercury. Take shelter until night comes.
Mars is on average 49 meters away from the Sun, and the closest planet on average is Mercury. Mars has lost its magnetosphere about 4 billion years ago, and since then lost about 1/3 of its atmosphere due to solar wind. So if you plan on visiting Mars, don't. From here on out, living directly on the outer planets just isn't possible, regardless if they have a solid surface to stand on, as the pressure and radiation would make our short life even shorter. So the question now becomes, what moons are habitable?
Starting with 8 regular moons of Jupiter, the general theme of radiation continues. The inner satellites not only are very small, but are caked in radiation. The Galilean moons don't fare much better, as Io, Europa, and Ganymede are a straight no-go. Leaving Callisto as our best shot, and it's surprisingly not a horrible choice. There have been detections of water ice, leaving us in a similar situation to Mars. But as we are far enough away from the Sun, we can explore in the daylight. As for all the other moons that Jupiter has, the majority of them are less than a kilometer in radius.
Jupiter is on average 167 meters away from the Sun, and the closest planet on average is Mercury. Fun fact, Jupiter's magnetosphere is the reason Callisto is our only choice. Instead of protecting us from solar radiation, it traps it, making anything close to it inhabitable.
Saturn is an interesting case. It has the most moons out of any planet, but we're only interested in Titan, as it has a dense atmosphere, but not dense enough to crush humans like a tin can. The pressure is only 1.5 times more than Earth, and it would take your sight away, quite literally. The surface of Titan is covered in haze, plus a thick atmosphere combined with the distance of the Sun leaves Titan's surface with only 0.1% of light that Earth receives, leaving us with the good news: no radiation problems. It's also not too hot. It's actually quite cold, but the cold isn't too much of an issue. Water, and therefore oxygen, can be found under the surface of Titan, making Titan a prime candidate for humanity to colonize.
Saturn is on average 308 meters away from the Sun, and the closest planet on average is Mercury. Its rings are only a couple hundred meters thick and have moons inside them. Not habitable ones, mind you, but they're there.
Getting to Uranus and Neptune's moons, not much is known. However, for our concerns, we run into the same issues with radiation due to a lack of atmosphere. The solution to living on them would be quite similar to Callisto and Mars, living in underground shelters for the majority of time.
Uranus is on average 620 meters away from the Sun, and Neptune is about 970 meters away. The closest planet on average is surprising, as it's same for the both of them. It's Mercury.
Before we go, there's one last thing to mention: living in space stations. Logistically, it's not a great idea. To protect us from the sun and cosmic background radiation, we'd have to make a very thick outer hull and a large enough space to contain everything needed for life. However, it's possible. Yet, there's still a downside that's not so easily solved and even applies to the planets and moons we've looked at before. Simply put, the lack of gravity. Without gravity, or a significant amount of it, there comes complications. For instance, when returning to Earth, you might die. But hopefully, you only aren't able to move for a while.